In this video, we are going to be finding the voltage across this 8 ohm resistor using source transformation. But before we proceed, what is source transformation? Source transformation is the process of replacing a voltage source Vs in series with a resistor by a current source Is in parallel with a resistor, or vice versa. So basically what you're doing is that you have this voltage source in series with this resistor, then you want to replace it with this current source in parallel with the resistor. And now the value of that current source would be V over R. And if it were going in the backward direction, the value of the voltage source would be V is equals to IR. Using this simple introduction, we will now proceed to using source transformation to find the voltage across the 8 ohm resistor. Now the first thing we're going to do is that we're going to start from here. We're going to isolate this current source and this resistor. So there we're going to separate it from the circuit like this. And we're going to perform a source transformation on the source. Now, if you separate it from the circuit, we would have something like this. And then the voltage across this resistor would be equals to 3 times 4, which should be equals to 12 volts. And then that means that we can replace the current source with a voltage source of 12 volts in series with this 4 ohm resistor. And by doing that, we would have this new setup. We know that at this point, we can replace this 3 ampere current source and 4 ohm resistor with a 12 volt power source. Notice the direction of the positive terminal, because the current is flowing in this direction, and the voltage source also has to direct current downwards. Next thing we want to do is that we want to perform a source transformation on these two components. In order to do that, we cut them off from the circuit again, just like before, and we perform a source transformation on them. Now, if you cut them off from the circuit, we would have something like this. Now, what we're trying to do is that we're trying to replace this voltage source with a current source, and we connect this 3 ohm resistor in parallel with it. And in order to do that, we would say that the value of current source that we're going to put in parallel with it would be 12 volts divided by 3 according to Ohm's law, and that will give us 4 amperes. So we put a current source in parallel with the 3 ohm. We would have something like this. Okay, we would have a current source with the current flowing upward in parallel with the 3 ohm resistor. Okay, so the next thing we want to do is that we want to connect them back to the circuit. The two sets of components that we've done voltage source transformation on, we connect them back to the circuit. And when we connect them back to the circuit, we would have something like this. And then the first thing you notice is that these two resistors, after we've connected them back together, they are in series. So we can then add the two of them together. We can solve the two of them together because they are in series. Say R1 plus R2 is equals to R3. So we have 4 plus 2, and the two of them equal to 6 ohms. And then we would have a circuit that looks something like this, with the 4 ohm and the 2 ohm resistors replaced with a single 6 ohm resistor. Then we can take it one step further by disconnecting this port from the circuit, and performing a source transformation on it, and disconnecting it from the circuit, we would have something like this. Okay, then we want to replace this voltage source with a current source in parallel with the 6 ohm resistor. Doing that, we would the current source that we would replace it with would be I is equals to 12 divided by 6, and that would be 2 amperes. And then we would have something like this: 2 amperes in parallel with the 6 ohm resistor. Then we can proceed to attach this back to where we removed it from, and by doing so, we would have a circuit that looks like this. Everything in the circuit are in parallel with one another. And if you are if you have enough experience with parallel circuits, you will know that you can basically rearrange the components in the circuit to make it a little bit easier to comprehend. And then you would have something like this. If you are also familiar with Kirchhoff's law, where the current flowing into a node is equals to the current leaving in a node, you know that this current, 2 amperes of current, is leaving this node. Okay, and 4 amperes of current is entering this node. And so therefore, what is left of the 4 amperes of current is what is leaving the node in this direction, and that would be 4 minus 2, which is 2 amperes. So basically, we can replace these 2 current sources with one current source, and that would be a 2 ampere current source. Okay. And the circuit would look something like this. Now, we have these 3 resistors in parallel, but since we are trying to find the voltage across the 8 ohm resistor, we're not going to be tampering with it, but we can combine these 2 resistors that are in parallel so into an equivalent resistor, and with that we would have the value of the equivalent resistance to be 6 times 3 all over 6 plus 3. That's the equivalent resistance, and that would be equals to 2 ohms. So we can replace these 2 resistors with a 2 ohm resistor, and then our circuit will be further simplified into something like this. Okay, and then with this information, we can then cut off this part again and do a source transformation on this side. If we do that, the circuit will look something like this, and then the voltage that we have to connect in series with the 2 ohm resistor would be 2 times 2, which would be equals to 4 volts, and then we would have a setup like this, where we have a 4 volts power source in series with a 2 ohm resistor, and then the circuit would look something like this. And at this point, in order to find the voltage across the 8 ohm resistor, we can simply use a voltage divider. And so the current, say this resistor is R1 and this resistor is R2. So the voltage flow in across, the voltage drop across R2 would be R2 multiplied by R1 plus R2 multiplied by V, and in this case 4 volts is V, and with that we would arrive at the value of the voltage drop V naught to be equals to 3.2 volts, and that is basically what source transformation is all about. Thank you for watching my video. See you later. Bye.